Number 33, they give you vector or vectors Q and P. We know it's vectors because it has a magnitude as well as a direction. It's two equal forces from out one point. Okay, so in grade 10, it was learned that if you have two vectors from one point, that we're going to figure out what the resultant vector will be using, like that, a parallelogram. Okay, so our resultant vector force, and they give it a name as well, will be R. Okay, so now they want you to go and look at the four different diagrams, A, B, C, and D, and you need to figure out which one is now the correct diagram. So you should know that this yellow dotted line is a copy and paste version of the original force Q, and that dotted line is the original force P's copy and pasted version. Okay, and remember, a resultant force will also come out of that same exact point from which the two original forces P and Q also comes out of. So if you then just close the picture, it can either be R and Q and P over there, but you'll see it's not an option. So the correct option that we're going to work with, I'm going to color it here in white. You'll see the correct one will look something like that. So you're going to look P there, R over there, and then Q there. And the correct one for number 33 will be option B for your question. 36, we have this, and they normally want to test your theory knowledge of vector diagrams, okay? And then they talk about that this is your angle theta, and it can be any angle between 0 and 180. So the actual thing they want to test you on is, if they give you a few options, what will the resultant force be, and what's the maximum and the minimum range of what this resultant force can be? So this is basics. You go and check, if we have this setup, what will the maximum range be? So you're just going to plus the 20 and the 60 together. So our maximum range, if you plus them, will be 80 newtons. And the same thing is, you want to check if it has a minimum value. So opposite direction, so we know it's a subtraction. So 60 minus 20 will give us a 40 Newton. Okay, so that is our minimum and maximum range if we have different angles on what the resultant force can be. Okay, and then if you go through your different options, you'll see that option C will be our correct option, saying that it can alternate between 40 and 80 newtons, and that's correct. It can't be anything less than 40, nor can it be anything more than 80 newtons for our resultant. Number 38, it's a bit of a difficult one. If you go and look there, we have a tension in a rope, and then we have a mass M, and then it has an applied force that's horizontal, and they say that everything here is in equilibrium. Okay, and then you need to go and check which one of the four options will show the correlation for when this object is in equilibrium. So it's a lot of writing, so I did it on the whiteboard. So if you want to draw a free body diagram of object M, you'll see we have our tension over there. That was our initial applied force, and then obviously because it has a mass, it has a Fg. So then what I automatically went to go and is to use the triangle rule. That's what we taught you to do when we have an equilibrium question. But then you see we have a triangle with our theta at the top over there. Okay, so obviously all these forces will have the tension plus our Fg, which is basically mg, plus our applied force, all to be 0 because it's in equilibrium. Okay, so then you want to go and check if we have an option of that, and you'll see there's no option like that. So if you go and scrutinize what we have over here, we'll see that we have a Ty and a Tx, okay? But again, that angle that forms, that theta, is towards our x-axis, okay? So Ty, in this case, if you use your trigonometry, will be the original t, but it's now cos theta. And it's not sine theta as what we taught you always, because if it was sine theta, then you had to use the angle that's forming towards the x-axis. That's very important to remember. So that means if t was cos, it means tx will be t sine theta. Okay. So now, if you look at, if it's in equilibrium, it means that the y-axis two values should be equal and the x-axis. So let's see, if we talk about our y-axis, we need to have that t cos theta equals mg or fg, same difference, okay? So if you change that, it will be that t cos theta, oh, I don't know what happened there, t cos theta minus our mg equals 0, okay? And so go and check if you see an option like that. Yes, there is an option B that will fit this, but if you want to, if you started with the x, it's fine, you can just check the x as well. The x would have been that our applied force, the x-axis now, the applied force equals our t sine theta. Okay, so it's just the applied force minus our t sine theta equals 0. So you just had to go and check one of those, but the correct one was B then, which is your t cos minus your fg, and that's that.